in the studio here with me right now. Mr. Paul, where you at, dude? Come on, get on stage, man. Let's get this happening. We don't have to.
Hey, man.
You too. So what's this right here?
Well, I know you like to hallucinate, so we brought you a +1 asset for your hallucination.
What is this? So this is, as I've been saying, I'm the shaman on this journey, and now you're coming bringing me gifts, huh? So that the journey.
I heard that's the custom, so welcome.
Well, dude, I know you got a talk for us. You all have been doing a lot of cool stuff when it comes to +1. And for those who haven't been experimenting with +1, it is happening now in Slack. So go ahead, throw something in there, ask it questions, but you're going to share all the learnings with us, right?
That's the idea, yep.
All right, and a little bit of peeking behind the veil, showing what kind of models you have going on in the background, why there's some hard problems, some easy problems.
That's it.
Did I just give away your talk?
No, that's it.
All right.
Spoiler. Hopefully.
I'll let you go for it. Have some fun. I'll see you.
Great. Thanks, Dimitrios. So what I wanted to take the next 20 minutes or so for is to essentially share how we've tried to bring some of these models into the products that we have in the companies across the group. As Euro mentioned earlier, and Dimitrios alluded to, we're a very large group of different companies doing different things. And I just wanted to kind of share that with you. Let's see if this one still works. There we go. Across the group, we serve about 2 billion users through the companies that are part of the group in various categories: in education, food delivery, in groceries, in finance, and so on. Some of the companies that we've worked with very closely on helping them understand where the value of AI and machine learning and now the new generative AI tools can be useful are here. And we want to share some of the things that we've learned in doing that. So we've actually been working on these tools for some time. I'm part of the Prosus AI team, and our goal has been to work with the companies I just mentioned to help them understand where they can apply machine learning bigger, better, faster. And so, of course, generative AI isn't something new, as certainly most folks in the audience will know. The GPT models have various generations before them. There's been generative models in other modalities, in speech, in code, and so on. And we've been working with them for quite a couple of years, and basically have been trying to understand what could be the potential value of some of these models in the products that we build for the users that we serve across the group. And so that's something I want to share with you. Now, some of the questions that we continuously try to ask, and we've got the Stormtrooper here, and this will come back at the end of the presentation when we answer these questions, but are at the beginning of this Gen AI wave about, maybe 12 to 18 months ago, when we were seeing that these models were becoming, much, much better, where first of all, is this a parlor trick, right? Everybody's trying to write a poem, everybody's trying to create a funny image, or is it actually use for some of these models that we're working with? So that's one thing that we're certainly trying to spend time on. The second is, what are those use cases across the group that made sense? And so trying to discover those, making sure that we invest the right time and so on then building out those use cases into the theme of like this conference, into production, right? Do users want these capabilities? And if so, how? Does it help learners? Does it help folks that are ordering food and so on? Should we build our own models, like Timothy just talked about for some of the things that we're doing, or are we better off from a just business perspective to consume the commercial models out there? And if so, when and which model and so on? And what does it take when we deploy these things at scale, not just for, for a couple of users, but as we talked about, hundreds of millions of users that use these products. So how do we figure that out? How do we try to actually discover that? So we're basically trying to explore in the last year and a half or so, very specifically, what are the areas that we could use this? And one of the ways that we tried to do that was through a tool that we called +1, because it looked and felt like a +1 team member. And it's available to all of the teams across the group. Basically, it's got any and all large language models, other generative models under the hood that you can interact with by asking questions like generate an image, transcribe this model, transcribe this audio, review this code, document this, and so on. All of the questions you might imagine, but in one interface, and making it really easy to talk to it, mostly through Slack. Thousands of users have been experimenting with +1 to kind of go on this collective journey. And One of the things that I wanted to briefly show you is how this looks and feels. So just so you can get a sense of it. So it lives in Slack, as you can see here. And it can do a variety of things. You can ask it to generate images of a pizza, and it will do that. It uses some open source models for that. You can also ask it to, for example, transcribe this meeting. Again, different models for that. And then maybe suggesting quotes, other tests that are happening. You can actually ask it to summarize internal Google Docs, and it will do that. This document's about +one's PDF processing features, which it's able to do. And of course, I also wanted to make sure that, Dimitrios is still here. He sent us this little picture from him on holidays, and we asked +one if it could actually caption this image. And very aptly, it said, "A man standing on top of a beach holding a stuffed animal in a life preserver." So it looks like Dimitri's life was preserved, and he made it all the way to Amsterdam safely. So good on him. So anyway, that's just to give you a feeling of how this looks and feels. And so we've had, as I mentioned, thousands of users, over 500,000 questions asked to +one in the last year or so. And we try to understand through some essentially history of these questions, what do people go to this tool with? Is it a parlor trick? What kind of tasks do people find useful? And you can see on this chart, it's a whole range of things, right? So a lot of actually software development things. It's a little bit the bias, maybe the makeup of our group, a lot of tech companies there, and the folks that are maybe more early adopters are actually often in those product and tech teams, but not exclusively. Lots of other different tasks, like product management tasks, general writing tasks, and about a 50-50 split between engineering and non-engineering. Also interesting is when you look at who is actually executing a variety of tasks, there's two things that we wanted to highlight, and that was especially surprising to me was, on the one hand, if you look at the software engineering tasks, yes, of course, the engineers are asking those questions, but it turns out there's actually a lot of non-engineers that are also asking technical tasks. The folks in finance asking to helping build a forecasting model. The folks in marketing that are now asking how to do more complicated, maybe formulas in Excel and so on. So in a way, it democratizes skills, which is a kind of a cool thing for any team, for any organization trying to build things. If you can give them access to these tools, that seems to be one of the effects that we observed. And the second thing is writing and communication, which is something that, of course, everybody would be inclined to use, but especially also engineers are apparently asking, in this case, +one and other tools to, for example, document the code or help me communicate what the user impact would be of this pull request and so on. And then if you ask people what actually they find, what's their experience when they use a tool like this one, there's a couple of things that come up. So the first is that they work faster. That's the productivity piece. But also a second order effect there is that they're able to do more. So more types of tasks, right? People, let's see, maybe the finance analyst example that's now able to write Python scripts with much more ease because they've got a co-pilot essentially helping them to answer questions and debug where they get stuck. And generally, that's the piece here, get going, right? So not be stuck, not have to wait to an answer, not have to go through maybe documentation you're unfamiliar with. It helps you get going. And when we actually did some very specific studies on trying to measure productivity and speed and so on, generally people are extremely clear that it does help them be more productive on a subset of tasks. Obviously, that's also corroborated by other research out there. And so the interesting thing is that if you're interested in using these tools for your teams, essentially one of the conclusions we were able to draw is that it's able to improve productivity the moment you make this available to yourself or start using it or your teams. Now, there's another process here, which is, well, what are the business use cases that actually come up? So besides productivity, which is sort of a horizontal implication of using these tools, there might be other very business-specific things that these kinds of generative AI models could be used for. Now, the example I'm showing you here is from one of the food delivery companies in Brazil, where, of course, they will talk and we're inclined to speak to +one in Portuguese. And you can see that, not surprisingly, of course, it understands Portuguese. The question here is, what are the ingredients and quantities for one person serving for a chicken stroganoff dish? Why is that person asking that question? Because typically in this business, there's tens of millions of different unique items, menu items. Think of it as dishes that restaurants upload that folks can order, and try to understand what goes in those specific dishes is important to help users discover that food. And so this is a question. It looks like these models under the hood, +1 is able to answer. It responds with a list of ingredients and the quantities. And then interestingly, this user then makes the next conclusion, says, well, wait a second. We've got tens of millions of these dishes. We want all of those enriched with this information. Can you structure it in JSON? And this is one example where we saw hundreds of cases where people are collectively discovering what these things can do, what these models can do for their use cases. And now you've basically identified this could be one of those use cases that would be extremely valuable, where in the past, we have talked about training, for example, our own models like Foodbird and other smaller language models to do exactly this task, basically categorize, classify, do enrichment on these dishes that now you can do essentially with a model that isn't specifically trained for that task, and that these are the use cases that were being discovered. Now, maybe one step back, on the bottom left of here, you can see that this particular case, there's 4 emojis, right? Thumbs up, thumbs down, heart, and the little Pinocchio. And that's a mechanism that we use to kind of collect feedback to understand, how good is this response? How valuable is it? And users have used this a lot to give us information and also signal, hey, this response was good. We could then go back to the models and so on to figure out in which case, which model version was doing better on specific types of tasks and so on. And so we're collecting all these things. Now, the first 3 emojis here, you will, of course, recognize what they do. I think it's very intuitive. But the 4th one is related to the mushrooms of Demetrios, right? It's the hallucination. We call it lovingly the Pinocchio emoji that we put there because when the model would make up answers, we wanted to make sure we captured that so we could see if there's something we could do about that. And if you look at, let's say, the progression of the feedback that we get specifically for this hallucination behavior, which, as many of you know, is one of the tendencies of these models, you can see that we started with 1 out of 10 or so answers fell into that category. But over time, we worked hard to figure out how do we get that down. And actually now, this is a stat from June, we're comfortably below 2%. And there's a lot of different things that we did to get there, and that continues to be a lot of effort, especially if you want to deploy these models in a safe environment. And some of the use cases that we have, whether it's education or otherwise, you want to make sure that you don't have hallucinations. And so how we did that is we looked at what are the types of reasons these models hallucinate, which models hallucinate, can we solve some of that through prompting, which we then did. Can we solve that through actually connecting these models to specific knowledge bases? And in fact, in particular in professional context, for example, in Slack, that turned out to be one important thing because people do ask these models in that team context about information that's internal. And so a lot of work was put in to actually make sure that you could ask these models through +1 to surface information, for example, that lived in Confluence. Right, so that's sort of the traditional RAG approach, making sure you do retrieval of the relevant information by having it available in some way, having it indexed either through embeddings or otherwise, and then put it into the prompt at the moment of generating the answer, and then doing appropriate attribution to the sources, as you can see here. Now, this is one of the things we did. We did many other things to try and improve that. It also is one of the lessons that we learned. It's very hard and context specific how you build this RAG pipeline. Are you for information retrieval? Are you doing just using embeddings? And which embeddings do you use? It's very different if you use documentation or text versus code. Do you do hybrid search? What's the chunk size? All those hyperparameters are very sensitive to the use case. And so we spent quite a bit of time trying to figure out what the best way is to do that for your context that you're trying to pull in. Now, all these lessons are the things that we were able to share with the group, and some of those have been used for some products that have been launched publicly. You will hear about some of those later also in the day and in the rest of the agenda. We'll have Brainly, one of the largest K-12 education platforms out there, talk about the work they've done to make it easier for students to get answers to their questions. Good Habits is an online education platform as well that has done similar things to creating educational tutor. As we talked about, in the food space, making conversational ordering easier in Brazil. In Portuguese, that's the work that iFood's talked about. And I'm sure many of you might have seen the Overflow AI announcement that Stack Overflow did, where, again, some of these same techniques were being used to help folks like ourselves answer questions and get unstuck. And there's many more in the pipeline that will be launched soon. Another thing that matters for us, because all these examples I just mentioned, these are not small companies. They each serve millions, sometimes hundreds of millions of users. The first question is, does it work? The second, once we've answered it, is, can we afford it? Does the cost make sense? So we continuously try to understand what are the costs of answering or fulfilling this question, or fulfilling this task. And we spend a lot of time trying to bring those costs down so we can actually deploy these things at scale. And you can see that we've been able to reduce the cost for a specific task over time. And again, there's a whole bunch of things that we do to do that. Some of that, as you will understand, has simply to do with basically choosing a cheaper model. Right, so if you have a smaller model, then that of course will be cheaper, either per token if you consume it commercially, or if you host it yourself. Fine-tuning some of the models, doing things like more efficient prompting, more efficient answer generation, picking between large context models, small context models, all of the different things that you can do here to, depending on your use case, pick the right model to make sure that it's economically feasible to actually launch this. Some of the things are maybe more obvious than others, but one of the things I thought was interesting in particular also highlights what we see in our group, because we operate in many different languages, is when you look at prompt economics, many of you will know you pay actually per token that when you interact with these models. And how does that total token billing happening? Well, you get essentially the tokens that you typically would put in for the instruction that you give the model. Second, the actual content. In this case, it's a translation example, the sentence you want translated, and the response. Now, I want you to think about this for a second, because what stands out when you look at this, at these tokens for each of these line items? We talked about different languages. Somebody mentioned Mistral and the reason for also potentially training on non-English data sources. You can see that this tokenization approach here is actually much more inefficient for non-English languages than it is for English. So for Spanish, in this case, you're paying double the tokens and therefore double the money for having that generated. And that also applies to things like code, right? So here you've got 1,776 characters in English on the left that require 356 tokens, but the same number of characters in Python are more than double. So again, this is something that we discovered because we're trying to figure out how we make this economically feasible. We are working in many different languages, almost 100 countries across our group that we serve users in. And so most of those, or many of those, will be in non-English. So thinking about how do you effectively use the models, what tokenizers, as you will know, it's not easy to change, when you're basically bound to the tokenization that the base model is trained on. But so picking the right tokenization can actually help you a lot when you go to non-English, to avoid the sort of non-English token tax that happens on many of the large models out there. Then I also want to talk a little bit about agents, because again, this is one of the areas which we try to discover, okay, does this work, right? People talk about them. In fact, it turns out, I have an example here with +1. We have created some agents. Here's one that does data analysis, where you can upload an Excel sheet. It then goes to a Python execution environment, and through a variety of let's say building blocks here, you can then have +1 generate, in this case, a chart, and do some of the analysis. Now, our conclusion has been so far that it's really early days in agents. When they work, it's phenomenal, and it really does provide you kind of a magical moment for a user. But they're very brittle, very sensitive to updates in the model, very sensitive to the prompt. When you start doing executions, the kind of room for error compounds, and they're very, let's say, non-deterministic. That non-deterministic behavior also compounds and creates kind of a strange user experience, because you never get the same answer twice, even if it does work. So we are exploring this area. We do think it's promising, but it's something that's still early days. Now the Stormtrooper is back, which means it's time to sort of wrap up and try and answer our own questions we had at the beginning, and recapping the lessons that we learned in essentially about a year and a half in deploying some of these models, across the group. The first question we had is, okay, how do you find value? Where do you find value? Well, one of the areas that we can confidently say we do see there's value to be had already today is on the side of productivity, and whether that's using GitHub Copilot, whether it's using a specific legal tool for marketing teams or +one or whatever it is, we can see the teams that use it are consistently reporting that their productivity goes up, and so that's something that can be had today. Then there's the question of sort of candy versus vegetables and the use cases, and what I mean with that is there's a lot of hype today, and so a lot of senior leadership in particular, but also other folks are very keen on going for the flashy use cases. Let's try and do something completely new. And I think there's a lot of innovation, experimentation happening in that front. And that's great. But at the same time, there's a lot of use cases that are maybe much more obvious where we're already solving the problem today. It's not really an innovation question. It's more about, can we solve this existing problem in a new way using these LLMs? Where I think this data enrichment example that I gave you about taking a dish and understanding or asking a model what its ingredients are, is it vegetarian, does it include allergens and so on, is something that previously would require collecting your own data set, fine-tuning a model, and then running that now is much, much more easier, and it's actually very valuable, so you can do that today. So finding a balance between going for the sexy stuff and at the same time also making sure that you pick up the unsexy low-hanging fruit, that's the second point there. The third is that even for those sort of novel use cases where you say, hey, we're going to build something that's entirely different, changes the user experience, whether it's a conversational food ordering bot, whether it's generating images for users and listings, doing automatic content generation, and so on. It turns out that it's often easy to do a POC, but especially when you're operating at scale, shipping that product in a cost-effective way is hard. And making sure you actually have impact on your metrics is something that still needs to be demonstrated in many of these cases. So it's much, much harder than often would appear when you see a successful POC. And then the second set of learnings is more on putting these things into production, right? The first piece here is that often when we're trying to discover where this value is, you actually don't need to fine-tune your models yet. I mean, we love to do it, and we're doing it, but I think for understanding whether you can actually have this task or this question answered, task done, question answered with any of these models, you don't need to necessarily start fine-tuning. I think Euro talked about that sequence, right? You can do some prompt engineering, you can maybe pick a specific model, you can, and so on, to make sure that you can actually try and experiment fast before you start thinking about getting all of the things in-house to fine-tune your own model, which then needs to be hosted, which has all sorts of other complications down the line. The second piece is around retrieval augmented generation. It's let's say the hot topic in town, and everybody believes that, and we do to a certain extent, that it can solve a lot of the hallucination problems. I think that's certainly potentially true, but actually making this work in a generalizable way where it works for and code and documentation and different types of formats of information, whether that's a book or a paper or Jira cards or you name it, and making it generalizable is very hard. And that has to do with, as I mentioned, your information retrieval strategy, your chunking method, whether you do, how you actually put it into the prompt. Do you do that all at once, or do you have separate, prompts that then you combine? And there's different approaches and strategies that you have to consider to make sure that you actually do that in an effective way with the right attribution. The third piece here is around a couple of really key fundamental challenges that still remain unsolved. The fact that a lot of these models still don't have up-to-date information and facts that are relevant to specific contexts of users, whether that's in a professional environment, in a team, or in educational content or whatever. The fact that they're non-deterministic and reliability is sometimes challenging, and the fact that we don't fully understand what these capabilities are. And last but not least, on agents. As I mentioned, they are very promising, and they're, when they work, it gives you a lot of excitement. But it's early days for putting them into production. Our experience, as they're brittle and hard to kind of have work in a consistent way for your specific use case. So that's it, and I open it up for questions. I think Dimitos is flying over in his llama.
Dude, awesome. We've got some good questions coming through. I've been monitoring the chat and seeing them, and I appreciate you giving some funny shout outs to my mushroom days. I've been actually scavenging for mushrooms, but not those kind of mushrooms, just the good ones back home, because it is mushroom season, for those who know. So
it's always mushroom season in Amsterdam. So
I was told not to bring up Amsterdam and mushroom connection because the Dutch don't like it that much, but you are Dutch, right? So, all right, we'll take it. Now, did you hit any capacity issues while running? Did that affect the user experience?
I assume it's for +1, you mean? Yeah. So all the time, actually, especially in the early days, doing essentially solving for the capacity constraints we had on the various models was something that we learned we had to solve quickly. So we do that through intelligent model routing, where we essentially make trade-off between three things: cost, quality, and latency. And in particular, latency is basically a capacity issue, right? If you don't have capacity, latency becomes infinite. And so where do you route your request, depending on capacity, is certainly important. And then ends up being one of the trade-offs you make, or one of the dimensions you trade off against when you send it to one model endpoint or another.
Yeah, I'm trying to remember this joke. It's like you can have two out of these three things: fast, cheap, easy, but not all three.
Exactly. So you have to choose. And so having a way to actually route between your models is one of the key components of a system like +1.
I can imagine. So in time, do you see yourself being able to predict hallucination responses with an appropriate confusion metric like IOW? What's IOW? IOW, are you improving your ability to monitor guardrail quality responses based on human feedback?
Yeah, I think absolutely. So human feedback is one of the elements that we, as I mentioned with the emojis and so on, we've been able to use to detect sort of the broad buckets that we see. So, people are asking questions related to internal, information that these models can't answer unless you give them access to it. Or people are asking about recent information, like what's the weather in Amsterdam today? And so if you have these buckets, you can sort of fix them in different ways. Some of it's through prompting, some of it's through dynamic prompt building, some of it's through giving it access. So once we know what the issues are, we can then monitor for the performance, not just through human emojis, but through some evaluations that we do basically on the back end to control for that.
So this is a great question from a past participant of the marketplace. Mariano is asking, in which cases do you see using LLMs more cost efficient than classical models in industrial applications?
Well, I think that's a great question. I think especially at our scale, we often find that you can still, with some of the classical models, far outperform, especially on cost. And sometimes on quality, if you've got the right training data to train your own models, like we've done. But I think there's also another case, which is like, again, going back to the classification example or data enrichment example, there's a lot of effort you save by just being able to use this powerful new model that actually you didn't have to collect your own training data for, you didn't have to train your own model for. You can just out of the box use a powerful model like this one to answer it.
So we've got one more question, and this again is this is a bit of a throwback, but Deep is coming in and asking, what do you think of the dangers of LLMs providing help to non-experts who may take its output as literal, especially for questions like, show me interesting insights, which, Deep, I feel like you're talking right to me.
Well, good to hear. Deep and Mariano, by the way, too, are here. So I think this is a really important point. Again, when you start deploying things at scale, this is a really, really important element. For now, this is one of the reasons why we put +1 out there so folks can test it in their teams, right? I think one of the really different things that we see here is, as opposed to many of the other tools out there which you're using by yourself, you can actually use this in +1 in Slack, and you can have your team look at what the answers are that it generates, and often step in to sort of have a social quality control, which is an additional layer of ensuring that you don't end up confiding in an answer without verifying it either yourself or through colleagues. There are other use cases where, in particular in education, which I think we'll talk about later, you can actually use some of these existing processes to ensure that the quality of the answers is really like using the subject matter experts that we have, the teachers and so on, that traditionally would either curate the answers that are generated by other folks on the marketplace, or in the case of, let's say, if you're dealing with content creation teams that actually create questions and skills assessment, they will then curate and see this content before it goes out to the user. So these mechanisms exist, especially in our companies which are large. And there you can make sure that you don't end up in this terrain where you're not sure whether the answer is actually to be trusted or not. So
yeah. So I want to ask one follow-up. And before we do, I'm going to mention to people that right now we get a little bit of a break, and I am going to be serenading you, Paul, while we are in this break. And it's an interactive break, so you can throw in prompts in the chat, and I will sing about them. So while everybody is getting their prompts ready, throw them in the chat. Let me make a song about it. But Paul, it brings up this question, the last thing that you said on having people see it before it goes out. Where are you thinking about having humans in the loop, or how are you thinking about having humans in the loop and touching on different pieces of that loop? Like, if there is a loop, where do you know where to put the humans, or how do you know where to put the humans?
Yeah, I think especially when there are user-facing applications at scale, like in education and so on, I think in most of the cases, I think almost all of them I can think of now, there's essentially a human in the loop that somehow checks the quality continuously to make sure that the answers behave at least to the quality that we expect from the existing processes that we have. And in cases where it's basically used for data enrichment, that becomes maybe less critical. Basically these models provide input for a next step in the system, especially if you're doing recommendations and so on. But I think as we are seeing with the way we've designed +1, it's supposed to operate in a human context with other team members, right? It doesn't do things by itself. I think that's clearly part of where the value of some of these models lies, in combination with you and me. So, which is what we're about to see, in fact, in a song.
Oh boy, are you ready for this?
I'm not sure, but I'm going to give you the same.